Hi, I'm Matt Needham, and this is my lecture on the Uniform Mechanical Code, Chapter 3, General Regulations. Starting right off, when we talk about, this is chapters about the general requirement for equipment, different clearances, and things of this nature. And one of the first things it mentioned is that equipment has to have a label on it or a nameplate on it, and that should tell a bunch about it, like its clearances, its ratings, whether it's good for indoor, outdoor, closet installation, things of this nature. And also just to kind of understand the difference about what the codes are about as opposed to specific pieces of equipment. The code is more about how that equipment is installed and interacts with the building, and not necessarily about what's going on inside the piece of equipment or the appliance. But it's saying that, generally speaking, that has to be approved by the underwriter laboratory. So the underwriter laboratories of the United States has to approve a piece of equipment as being safe to go in, and then the building inspectors in the code just make sure that it's UL approved or underwriter laboratory, and then how is it installed, what are the clearances, is it anchored properly, and so forth. And one of the first points here in general regulations is that any piece of equipment, and they just have to have some kind of demarcation. They say 50 volts. Well, really nothing works at 50 volts or 60 or 70 volts. In this country, it's all 115, 120, and they're saying you have to have a receptacle nearby within 25 feet so you can hook up your equipment, your tools, your saws, your lights, etc., for testing, and also we'll get involved in that. I guess I'll cover it now. Is if you're on a rooftop, again, you also have to have an outlet right there next to the unit, and that outlet has to be like electrically upstream of the unit. It can't be where you take the disconnect and throw it off, and then you can't have plugged in your light. You see what I mean? And you don't want, it's not where you have to have the disconnect on in order to have your light on, because then the unit would be unsafe and you might be working on it live. So we have these kinds of regulations. There's a mention here in the chapter about oil, and oil heat is burns hotter than natural gas. It's probably one of the dirtiest burning, worst for the environment. And we don't allow it here on the West Coast, at least in California, to actually burn the oil here to make, to run generators or produce heat. On the East Coast, in the north and older areas, yes, and the state that probably uses the most is Maine. Just a little trivia for you. All right, now let's move over to personal protection here, and I'll read a little blip here on the next page. Personal protection. A metal guard shall be provided around exposed flywheels, fans, pulleys, belts, and moving machinery. There are portions of a heating, ventilating, or refrigerating system. Having on guards, because even if you're not actually working on it, a lot of times in my experience in all these years, walking through equipment rooms, air handler rooms, to get to a roof, to get to a cooling tower, sometimes they're messy. And there's little pieces of copper on the floor. And people have left these fan guards off, and you have these big pulleys with these belts spinning very rapidly, and the light, it's an equipment room, and the light bulb burned out, or two of the three light bulbs burned out, and it's very dimly lit in there, and then you step on a piece of little copper, and you slip, and you put your hand out, and you lose a finger. Or a hand or something. So it's important to have these guards on the equipment at all times, not if possible, just period. Okay. Let's move on here to the next page, alternative materials and methods of construction and equivalency. So it's not that the building code is so rigid and it's updated every 3 years that if something new comes along, or you're some kind of like Doc Brown, if you've seen Back to the Future, he was always creating, inventing his own stuff. If you create something that works and is good, and you have a open-minded, which is rare, building inspector, they can say, yeah, that's equivalent, that'll work, that's safe, I get it, and that's okay, because you don't want to stop progress. I mean, had the building codes just stopped, or the idea is that whatever was in 1880, we're just going to keep doing in 1870, 60. I mean, buildings wouldn't have indoor plumbing or electrical or anything, right? So, I mean, there's this kind of process and then patent pending, and it takes a little while for things to become generally accepted, and there's a little struggle in there initially for certain products or building inspectors that may not be up with the newest code, and so there's a little issue with that. But the code isn't designed, it's designed for safety. It's not to inhibit new technology that may be as good or better, or just individually created by some kind of Doc Brown person, which I aspire to be. Okay. All right, let's move on here to closet or alcove installations. Once in a while you'll get a piece of equipment that says, yeah, it's okay, it has to be approved, made by the manufacturer for closet installation. And the main thing that we're probably dealing with here is upright furnaces that go in a closet where you have a door, and then you open the door, and then there's a furnace. That's designed to be in there. And and there's a lot of things that generally violate the code, but since it's designed appropriately, it's okay. Like one of the codes that we deal with was every piece of equipment that you work on and a panel that you can take off in front of that panel, in front of that equipment, you've got to have a 30 by 30 area, a platform for you to stand or sit or kneel on, and for you to have room to work on and take the panel off. Now, that's not the case with a furnace that goes in a closet, like in a home. And in Southern California, most of the older homes that were built had a furnace like this that was then even converted to having air conditioning with a split system. And then probably from the late 80s, early 90s on, people tended to put them more in attics, so that for cosmetic reasons primarily. Now, those are designed, those furnaces, where when you open the door, you're not getting in there with the furnace. You're reaching in around, but your body's not trapped in there with possibly bad fumes or lack of air. So that's one consideration. And the panels you take off can be put outside the closet. Everything is designed, like if you want to take the fan out, you have to be able to reach in there and get the screws, but then the whole thing is made so that everything slides out the front and you can take it out. And there's not these side panels that you have to get to. It can be tough. The one part, I recently installed a new system in my old house, is sealing up the ductwork in where the unit attaches to the ductwork in the back. I mean, my long arms were pretty helpful there in doing that, but generally all the panels you have to take off and whatnot, everything is where it comes right out for you. So that is what we mean by closet or alcove installations, and it has to be labeled that way. Let's go down to anchorage of appliances. So you want to anchor it according to the manufacturer's installations, and then some exceptions for things that don't need to be anchored in place would be residential washers, dryers, kitchen ranges, and equipment defined as portable. So those things aren't necessarily anchored in place. And then sometimes things change. Like in a sense, I know that here in Los Angeles, there's a new code. If you get a stove that's put in now, it has to kind of have an attachment where it can't tip over, where there's sort of a latch on it like this, so that no kid can open up the front door of the oven and stand on it and have it tip over. It's not really anchored to the wall. It can be lifted off, but that's like a new thing that's come out the last few years. But washers and dryers and things like that, people tend to take them when they move, and you also they have like flexible connectors for like the exhaust for the dryer, and you can move those out and remove the dryer washer, have it fixed or clean behind there, or clean out the vents things like that. That's really not considered to be part of a building structure. And you're going to find a lot of exceptions that we talk about with washers and dryers. One thing being that a dryer in a garage doesn't have to be 18 inches off the ground because it's manually operated. It's not going to generally start itself at 2 a.m. in the morning where you could have a safety hazard and a fire. It's manually operated, so they kind of look the other way in regards to things like letting it sit directly on your garage floor instead of being 18 inches or above, which your furnace, my furnace and hot water heater, like 22, 24 inches above in my garage, okay? If something is on casters, which mean wheels, it's movable, and it's sitting somewhere, it has to have a restraint so it can't just roll off during a little earthquake and smash somebody, okay? And then on identification of equipment, particularly on, if it's in a machine room or particularly on roofs, that's my pet peeve, it should be properly labeled. And this is one thing that I've seen over the years where it's not. Maybe somebody wrote on there with a Sharpie the day before it was approved or whatever, but having a really good long-lasting nameplate that says that this package unit serves the northwest corner of the second floor. There's been a number of times, I hate to admit, when I've been on roofs the size of football fields with 100 package units, and it's a 3-story building, and things were not labeled. And this is even before cell phones, so I would have to like walk my steps, and then if I didn't have anybody to talk to say, hey, I'm going to turn the unit on and off, is air coming out of this vent or not, you could see my dilemma. There's been a couple times when I've actually started to work on the wrong unit over the years. Embarrassing. But that's, if it's helpful if you have a nice little tag on the thermostat and that tag would match up with the equipment. And if you're maintaining a building or getting a maintenance program together, it's going to save you a lot of grief. Because it can be difficult when you have 2 units right next to each other, and one serves the 3rd floor, and the other serves the 2nd floor right beneath it, and they're package units, and they're not properly labeled. And then you're trying to run up and down and turn things on and off, or calling somebody or something. It's easier now with cell phones to say, hey, is air coming out of your vent above your desk? But that's an important part, is properly in long-term labeling things to say what area does it serve. Because sometimes it's not that apparent, especially in large facilities, large buildings, okay? Let's move on. Again, equipment that is on roofs needs to be rated for the climate, and also the fasteners. Generally, like when you have things that are corrosion resistant, they are zinc coated. Even think about when you go to buy a box of screws at Home Depot. Some are rated for indoor use and others for outdoor use. And you'll see that the ones for outdoor use are zinc coated, right? And we have galvanized piping. What is galvanized piping? Galvanized piping is nothing more than steel piping with a zinc coating on it. So things have to be properly designed for the environment that they're in, okay? Now on clearances, again, from the roof, any piece of equipment has to be at least 6 feet from the edge of the roof. I've seen this violated. One time I worked on a package unit where one of my legs literally had to hang off the side of the building to take a panel off. I was up pretty high. So you've got to have at least 6 feet. Now, the exception to that is this, that if a package unit is 36 inches, if it's 4 feet from the edge of the roof, and you have a parapet or a guardrail 42 inches high, that isn't going to allow, anyway. Now, somebody like Boban Marjanovic or Yao Ming, they could probably fall over the 42 inches because, but anybody under 7 foot tall is not going to just back up and trip and then fall back over a 42-inch high guardrail. So if a piece of equipment is 4 feet away or 5 feet away from the edge of the roof, you have to have a guardrail, a parapet, 42 inches in height, okay? And even you'll notice in one of the videos, another video that I show in the class that I'm teaching, it talks about that. And it talks about a parapet around your roof. There was actually a building code in the Bible that was mentioned, you know, way more than 2,000 years ago. Okay. All right. Now here we go. Let's go to again, electrical power. Again, you have to have a means of disconnecting it right next to the equipment so you can make sure that you shut it off and lock and tag it out. And then you need to have an outlet nearby so that you can plug your vacuum pump in, your recovery unit, your drop light in case you have to work while it's dark. And that can't be downstream of the disconnect, where the only way your light is on is if the disconnect is on. Then you're trying to change a motor with live wires. No, no, no. It's got to be upstream. It can't be on that circuit, okay? Just to be clear about that. And then here on access, it talks about buildings that if it's more than 15 feet in height, it shall have a means of access to the roof unless something has been approved by the authority having jurisdiction. So generally, we don't have an 18-foot step ladder can get you up to a roof that's 15 feet high. Now, there can be older codes that in older buildings where they have these 90-degree ladders against the wall. We're trying to get away from that because it's dicey. I've done it. It's difficult, and we'll talk about some of those requirements here in a minute. But they want you to be able to get from if it's a 3 or 4 or 5-story building, they definitely want you to be able to have a ladder inside that goes up to the roof or stairs that go up to the roof, and not where you're just going up a 90-degree ladder, which is dicey anyways, and I've done it thousands of times. Yeah, so, and also here on the 15-foot, by the way, each step of a ladder is generally 12 inches apart, so you can see how far you're going up just by counting the rungs of a ladder. And then we have an access door shall not be like a scuttle or a hole going to a roof. Needs to be at least 22 inches by 24 inches. And then attic access needs to be a little bit bigger. If you're trying to get into an attic and not a roof, it actually has to be 22 inches by 30 inches. I think that has grown bigger over time because I've certainly seen smaller than 30 inches, 22 by 30 in a lot of older homes. Okay. Now it's kind of interesting about permanent ladders being attached to a building, like on the outside or going to the roof. They have certain regulations, right? They have to regulate everything, otherwise people say there's no law against that, and then they make some kind of crazy, unsafe thing. And every little bit of the design of a ladder is here. The side railings shall extend not less than 30 inches apart. So you've got to have side railings you can hold on to. And then if you're going up, if there's an older building, the old rule was you've got to have a landing, like if you have a 90-degree ladder. Generally, that's not approved anymore, going up 30 feet. But I've worked on buildings where on the side you have to go up way more than 30 feet. And if in some area that's still approved or okay, or you're working on an older building, you need to have a landing where you can take a break and catch your bearings and rest or be rescued at 18 feet. So every 18 feet, you would need it. But again, working like that is kind of dicey. And then the width shall not be less than 14 inches. So you've got to have at least 14 inches so that you can walk up the rungs. So each rung needs to be at least 14 inches wide. And then the rung spacing shall not be more than 12 inches apart. And the rungs are usually about 12 inches exactly. And then the space shall not be less, the toe space shall not be less than 6 inches from the end. So that you don't have just a ladder up against the building and you're standing on your toes. It's further back and your shoe can get on there where you can balance your weight. And it has to be 6 inches off the side of the building. So you see, every little bit of the ladder for safety has been thought of and is part of the code, which is a good thing. Okay. Some people like to show construction sites in other countries where building codes maybe aren't followed as strictly, and you can see some drastic things done in construction. That's all I want to say about that. There's some videos out there on the internet showing buildings going up and some pretty unsafe working conditions. Okay. Again, permanent lighting shall be provided at the roof access. The switch for such lighting should be located inside the building. So you have to have a switch that you can hit so the roof lights up before you actually go onto the roof if you're going up a ladder onto a roof. Okay? All right. Where you have a passageway, like maybe underground or something, you've got to have at least 6 feet in height if people are going to walk down that tunnel. And when I used to work at Valley College, we had these tunnels that were more than a quarter mile in one direction and just about 6 feet high. Sometimes I would just barely rub my hair, when I used to have hair, on the lights. So yeah, so if I went back and walked those tunnels now, I'd probably be okay. Probably a quarter inch shorter too now. Yeah. All right. Again, work platforms, you have to have a 30 by 30 area. And then installation in garages, we mentioned it. You have to have equipment in a garage at least 18 inches off the ground. Now, not a washer and dryer, that's an exception, but a furnace, a hot water heater, etc. And because, you know, these things use natural gas, and if people store paint and gasoline and other flammable things, and they don't want somebody tipping that over and it spills on the ground, somebody's got 10 gallons of gas and it tips over and flows over to a hot water heater that's now lighting off, right? And I would be careful about running your dryer if somebody's going to be messing around in the garage, because you know you do have that equation there where it could be disastrous. Okay, so that's why they're required to be that far off the ground. Also, in case there was a flood or something, they're also off the ground. Okay. Okay. So under pilot lights, if you have a standing pilot light, you have to have a means to shut off the equipment. Or an ignition failure. So what we're saying is, like hot water heaters, even brand new ones, and I just put a new hot water heater in my old house 2 weeks ago. Okay. Yeah, they have the little push button. You have to hold the pilot in, and I do other lectures about how you open it, the pilot, with your thumb, and then the thermocouple has enough power to hold open that which you opened with your thumb, but not enough to open anything. That's another story. But anyways, if the standing pilot were to go out and the gas valve were open, then gas would just flow out. The worst thing you can do with a stove, with a furnace, with a hot water heater is to have the gas valve open and flowing out and no means of ignition that you're controlling with a pilot, with a sparker, with a hot surface igniter, because then you're filling up a large area with natural gas, and then if it hits a source of ignition, boom. So we never want that to happen, so we usually have a thermocouple or a thermal pile. Actually, the new hot water heater I put in, because it has a little electronic thing on it, it has basically a giant thermocouple called a thermal pile that generates its own electricity by iron and constantan getting heated up and throwing an electrical signal. Another story. All right, so you've got to make sure that those are always operational. Now, the exception to that might be an old stove. Sometimes I used to have an old stove where you had this tiny baby standing pilot, which we've tried to get away from, which they don't make stoves like that too much really anymore, where it was on all the time. Just this tiny flame, and then you turn the burner on, it would light off. Now we have tick, 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 and that stove uses electricity. A lot of stoves from the 70s didn't. They would just have a baby light on. They didn't use electricity whatsoever. You open the valve and woof, it would light it would light off. But if that blew out, then and somebody turned the gas on, they would start filling up the kitchen with natural gas. Okay. All right. The maximum temperature for a furnace, the limit control for like a natural gas furnace, is 250 degrees by code. You have to have a thermostat that says, hey, if the temperature coming off this furnace right above the heat exchanger is 250 degrees or more, the whole furnace has to shut down. Something's unsafe. Okay, it's getting too hot. Now that's the code and the law, and I think it kind of goes back into the mind of that 15 psi with high pressure boilers and water boiling at 250 degrees for 15 psi, and so they use the 250 like they use the 15 for the high pressure boiler. Now most manufacturers, I'll tell you this, for furnaces nowadays, actually, again, the maximum is 250. Like they're like, that's ridiculous. You know, we generally, the furnaces when they're running put out air like 110, 120 degree air comes off of them. They usually heat up the air around 50 degrees. So they put it like 150 or 160 degrees limit switch, saying, hey, we're going to just have this thing shut down if the temperature coming off of it, the air, is 160, all bets are off. But by code, the old code, going back probably 100 years, we've had this concept of 250 degrees, okay? And then a little bit with electric duct heaters, they're like, well, that shouldn't even be as hot as burning. Little electric heaters aren't like fire, so the actual code for that is maximum is 200 degrees, okay? And then the nameplate on fuel burning equipment has who is the manufacturer, the input-output rating, let's say for a furnace, and it works like this, that if you have input rating of 100,000 BTUs of natural gas, perfect heat quantity, and it puts out 82%, 82,000 BTUs, that's the output, and it would be 82% efficient. Again, now in California, as of just the last, probably at the end of 2019 and going forward, we're not allowed to put those furnaces anymore. We have to use the high efficiency ones where it's more like the natural gas rating 100,000 for, say, a furnace. It has to be 95% efficient. You've got to get 95,000 BTUs out into your supply air or your plenum, which requires a condensate drain and a separate source of combustion air, and we'll get involved in that. Okay, again, the BTUs per hour, the model number, the serial number, how to light or operate it, and then is, you know, like an ability for the UL to have their stamp on there. Okay. I also think that a lot of times one of my pet peeves with all nameplates, first of all, I think they're too small. I think it needs to be a bigger, more solid, bigger font, if you like. And also, I think on all equipment, all air conditioning, refrigeration, heating, all that, the manufacturer date should be right apparent, which it's not always. When was this made? It doesn't necessarily mean when it was installed. A lot of times, equipment may be installed 7, 8, 10, 12 months after it was first made, if it was sitting around for a while, okay, before it actually got put in, where it was in a manufacturer's warehouse, and then there's a delay, and it was shipped out with some others, and then the supply house had it for a while, and then somebody bought a bunch of them and started a construction thing, and then had to stop for a while because of a permit problem, and then they actually installed the last units 13 months after it was made. But at least there should be, I think, the date it was manufactured stamped on there, but that's not the case. Then heating and cooling equipment, heat pumps and cooling appliances, similar. It's also going to make you have the volts and the amps on there, along with the type of refrigerant and the test pressure. Let me talk to you a minute about test pressure. People are very confused about refrigerant and test pressure. Test pressure has nothing to do with the operating pressures of the equipment, the low side pressure, the high side pressure. What the low side test pressure is saying is that the manufacturer guarantees that it's leak free up to this pressure, And the high side test pressure similarly says it guarantees it's leak free up to this pressure. And whatever you do to put like dry nitrogen in to leak test it in the future, don't exceed these pressures. That's what it means. It has nothing to do with the operating pressures or even the standing pressure when the system's off or anything like that. You know, generally a good rule for almost any system, a good rule of thumb is if you leak check it and do a standing leak check with 150 psig of nitrogen for most systems, not every single one, that's a pretty good place to be. Okay. Let's move on. Condensate pipes. Again, when we do cooling, air hits a cold coil, water falls off, and then we've got to get rid of it. And most of the time we don't have a pump. We're relying on it just to drain with gravity. So you just need the slightest downward grade of 1/8 inch per foot. You can do more. I remember one time I was working in an attic and this lady had water on her ceiling and it was very humid and hot and it hadn't occurred before. But the problem was that when it came off the unit, it went downhill. But then before it got outside, it went over some stuff deep in the attic, hard to see, and it went uphill. And when it was very hot and humid and running all the time, it actually overflowed a little bit because of that. So it's got to be the whole way going downhill. You can't have some big hail in the middle of your drain line. You're going to have a problem, okay? Again, with condensate lines, you know, people always think like, well, yeah, you need a 3/4 inch line. You know, yeah, that's small equipment, that's residential, but up to 20 tons of cooling, yes, you do. But for 21 to 40 tons of cooling, a 1-inch condensate line. For 91 to 125 tons, an 1.5 inches, and up to 250 tons of cooling, you're going to have a 2-inch diameter. You're not going to really find individual coils that are more than 250 tons. You really shouldn't. You may have a 5,000 ton chiller, but you shouldn't really be having an individual. There aren't too many out there above 250 ton chilled water coil, we'll say, or certainly not an individual direct expansion evaporator coil. Okay. You have to have a means of clean out for the condensate so that, because over time dust and gunk gets in there and you can plug up the condensate piping in the drain, you have to have a means to clean it out. And then equipment needs to be installed with air filters for heating and cooling and makeup air systems so that you're getting the dust, you're getting some of the dirt out of the air before it comes not only into the building, but before it plugs up your evaporator coil or your heat exchanger or your ductwork. You want to get that. And you'll find, because of air filters and things like that, if you get involved at all in duct cleaning, what you're going to find is the return air, the outside air before it hits the filter. Those areas can be very dirty. But the actual supply air, where the air comes out, if you were to take that vent off and look in there, yeah, over the years, you may have some dust, but you're not going to have any kind of thick buildup of anything unless somebody ran the system for years without an air filter, okay? Now, the outside air, you can't just take it from anywhere. You have to be careful. A couple of general rules is, like, let's say you have a chimney vent or exhaust off of a furnace, or an exhaust fan, or a plumbing waste drain, or the side of a building where you have a parking lot or a parking structure, a garage. Those are all places where you don't want to take your fresh air from because you're taking kind of nasty air and putting it into the building. So we have those regulations. You're not able to take air from there. You want to take it up high from a clean source and not have it some kind of pollutant that can get in there, whether it's from an exhaust fan or a kitchen hood or a chimney vent or combustion exhaust or anything like that, okay? You want your fresh air intake for the air conditioning to be as clean as possible, right? You don't want fumes or carbon monoxide or anything like that, okay? So that's under prohibited source. Also for closets, toilets, kitchens, away from all that. Okay, that ends my lecture for general requirements. Thank you.